Um, Good afternoon, bona tarda. What I'm going to present is not something that's already done or something finished, but something that's being done. And the focus of my presentation is to check that, as I've been working on this alone, that I'm not doing anything that is going to be completely useless. I would like to gather some opinions on it, and well, it's work in progress. Don't expect it to be very stable, and don't expect something very spectacular on the end or anything. Okay, I'm going to present a different game engine for Blender, and basically, well, the presentation will first talk a little bit of why is this being done and what's currently in the game engine in Blender. Then I call it paradigm, the new way I'm trying to use to describe the games in Blender. Then I'm going to show a very small example, more a proof of concept than anything else. And then I'm going to talk a little bit of what I have in mind for the future. And of course, well, I think we can leave the last point for after the presentation from Jordi, because he is going to talk also about the game engine, so maybe we can do that together, kind of discussion about the game engine in general. But if you have any very specific question on what I have presented here, you can ask it then. Oh. Do you want me to repeat everything again? Okay. So the context. Blender has a game engine, you already know that, and it's very good. It has very good points that no other game engine has. First of all, it's completely integrated with the production suite. Second, it allows to develop visually the game logic, and then it's open source and free software. Probably it has many other points, good points, but wouldn't list all of them here. On the negative points, and this is my humble opinion, some people can argue that that's not true, but I think it's not maintained anymore, meaning that there is still some people doing things, integrating new things like recently the new physics engine, and people mighty developers that are adding new features on the current game engine. But I think that overall it's not really maintained. Proof of this is the discussion on leaving it out of the Blender releases that are currently happening. Another bad point of the current game engine is that the technology it's using is OpenGL 1.1. It's quite old. It's not bad, but it doesn't even really support the new things of the programmable pipelines or the things that are featured in the new graphics hardware. And then, and this might look like a contradiction with the previous point of visual development, whenever you want to do something a little bit more complicated, you have to end up doing Python scripts if you want to do it with the current game engine, because the visual development system is good, but it's quite strict in what you can do. So the goals of what I'm trying to do are these. First, try to use newer technology for the game engine. Especially when I speak about technology, I'm referring to graphics. In games, you can find many other technologies, but graphics is my part. So I would like to make an OpenGL 2 based with a programmable pipeline and shaders in the GL shading language. Then I would like to keep it integrated in Blender, or even integrate it more, as the new graphics engines can do many more things than the previous OpenGL 1 couldn't do. I would like to do things like using the real materials you are using to define scenes in Blender instead of using only vertex colors and diffuse lighting with funk per vertex. And this is something that can be done well, you cannot do global illumination, but you can do different lighting functions if you use them locally. Then the main goal of this project and also what I'm going to introduce here is to generalize a little bit the visual editing system. And not only use it for the in-game logic that is being used in the current game engine, but also use it to define other parts of the game. Like I'm mentioning here, the render pipeline, which can change a lot from one game to the other, or the data construction process. Some games need some graphics data and some games need different graphics data. For example, you can have normal maps or light maps, and you have to define a pipeline to construct these assets. Then another goal of this project, as any project, but especially open source projects with many developers that come and go all the time, is that it has to be quite modular and easy to maintain, easy to start, and easy to extend. And in very, very long term, and I would like to build a community, or I think a community should be built around the game engine. There is already a community, but I'm talking about a developer community. Then, I think we have to be realistic with the game engine in Blender. We cannot really try to call Electronic Arts and tell them, please use this engine, it's very good, because they are not going to do it. The games industry last year has been growing a lot. In fact, since 3 or 4 years ago, it's moving more money than the cinema industry. Now, current video games are made with teams of hundreds of people and with millions of euros. And they don't need to use an open source engine for the game. They probably will develop their own engine. However, here I want to specify that I'm talking about the game engine, not about Blender itself. I think that Blender is useful for these kind of companies as a production suite, not as a game engine. However, apart of this, computer games nowadays have another lane. There are small companies that are starting. There are independent developers. There are amateurs, hobbies that don't want to do professional things. And I think for these people, Blender is ideal because they have everything together, and of course it's free, it's open source. So I think that the game engine in Blender should target these people. Also, it should target the teaching. Some universities are starting to get into video games, and research people of graphics, people that is doing research in graphics at universities, tend to do good things, but that are not useful because they develop them isolated, and then when they finish their research, they throw it away and do something else. If they were working in a framework that was already there, those things could become useful eventually. And maybe one day in the future we could have something like Project Orange, but for video games, if this thing evolves, and maybe we can produce completely open source video game. Okay, now I'm going to start with what I call the paradigm. The basic thing here is it's based in the logic bricks in Blender. In Blender you have sensors, controllers, and actuators. You can plug them together and make them do different things to control the logic of the game. What I'm trying to do is to generalize this and break the three-step chain and have what I call modules that can be both a sensor, a controller, or an actuator. Thank you. And plug them randomly to produce whatever game logic you want to produce, or whatever logic you want to produce for the game. So you can describe a process by plugging various of these boxes visually in Blender. However, then the game engine basically is only going to run this kind of pipelines. I call it pipelines because I started them seeing as pipelines, but they are not no longer pipelines. I'm back. We'll end up small boxes. Okay. Till now, that's suitable for the game engine in Blender. First of all, it's very useful for game data construction, and while designing, my idea came when I was designing the asset pipeline for a game that I'm developing at work. Has nothing to do with this. But you have to define all the processes and steps to build the data that the game is going to run. And I thought that that could be done visually. And then I ported all this to the other parts of the game. For example, for the rendering pipeline. The rendering pipelines tended to be only one on the times of OpenGL 1.1, etc. But now it's completely different from one game to the other. You use many passes, many render targets, many different shaders for every frame. So you have to be able to define that in a flexible way for your own game. And of course, this is also useful for the game logic, which is what was already being used in Blender. And but in this last part is where they shouldn't be called pipelines anymore, because it's not about data flow, but about events and signals. However, the diagrams are the same. So this is a very general paradigm, and for this reason has many problems. When you define something like this, ABC, visually in the boxes in Blender, when you are trying to imagine what this is going to be, what this is going to do when run, you have a problem. You don't know if B is going to run before C, or C is going to run before B. This is meaningful for some of the processes that we've been mentioned. I will show in the examples cases where you can see this, and it can be a problem or not. So when you visually design a diagram like this, it's not defined. Then we can have a similar case, which is the opposite. When a module receives data from two different other modules, you never know when you are executing the pipeline what's the order of the data incoming. The other weakness is, I mentioned it already, what's the meaning of this link? Sometimes you want it to be objects flowing from one process to the other. Sometimes you want it to be a signal that activates something, like the events in Blender. It's not very defined yet. Finally, there is another semantic problem. Imagine this module that wants to accumulate something. For example, it's going to sum all the numbers that come as input, and then want to give the output as a number also. With this diagram, the module will never know when the data is over, so when he can just proceed with it. So this is also a problem that introduces the needing of meta information. Let's define. It's quite simple at a development point to define one of these modules without really having to know what the rest of the modules do. And the third, and this is quite important these days, it allows parallelism in almost all the processes. This is quite important for game engines and game and real time and all this stuff, when processes tend to be dual core and you tend to have more than one processor, like the Xbox 360 that has, I think, 3 processors or something like this. So parallelism is something that has to be exploited. Now I'm going to try to show the proof of concept example that I've been using to develop this. I'm going to run my own branch of unstable Blender, so I don't want to hear anybody laughing if it crashes. Quite different. Okay, I've added my stuff temporarily because this is not official, it's only on a branch. I've divided the game engine into 2 sections. The normal section for the game engine is still here, and this other thing is what I've added. Then this button space here is now a pipeline editor where you can create graphs like the ones I've been showing in Blender. Okay. This will be the root process that controls the game that you are going to see. It's a very simple game. It's called a game, but, well, actually, it's not that. Here, each of these modules represents one process defined with different models inside of it. I will show them now. But top level, what you can see is first a process that converts the data from Blender into the game engine data. Then in here, you can see a pipeline that's going to render this data to show the intro, which is more or less what you see here. And then a pipeline that controls the logic of this intro that basically it fades out when you press a key, and then it switches control to the rest of the processes. These other processes here, there is one that selects the current level that you are playing. I have two. And then you have a process that controls the physics, one that controls the user input to define the platform control. You will see the platform in a minute. And then the one that defines the rendering pipeline for this level. I'll have to scroll this because... Okay, this is quite complicated. Try to zoom. First, we have this process here that exposes the Blender scenes. So it's going to throw all the Blender data types through this pipe to this other process here. This one will select the one that has this name in Blender because we want to treat this special. It's not a level, it's an introduction scene. And then there are two different paths depending on if you are in the introduction or you are processing a level. Just going here. That's quite complicated because I only have straight connections right now, so I cannot really lay out the modules in a better way. Here I'm working with Blender data. I'm selecting the Blender objects that are meshes. I'm showing its parts. From each Blender object, I'm taking the mesh, the material, then the transformation in the scene graph, the name, etc., and some physics information. Then this module encapsulates the transformation from the mesh type in Blender into something more friendly for the game engine. And then it creates objects for the game engine. I'm not going into detail in all of this. Creates physics information for the physics system. The physics system I've been using here is Bonet also. That was recently introduced in Blender. And then it packs all the objects in each scene and gives it as a level, as an output of this pipeline. This export module, what it does is create a connection on the root pipeline. One of these three connections here. Each connection is an export inside this module. So you can export data to other pipelines and connect it. What else? I'm not going to show all of them because it's going to be boring, but that was a data construction pipeline. You can define the way you want to construct the objects for your game. Then I'm going to show some logic one. Okay. This pipeline is about logic. It actually starts with waiting for keys and also processing the time, but this is another thing. Waiting for keys, and when the user presses a key, it fades out for a certain amount of time. The screen, you will see that this connection here goes to the graphics pipeline, and so it is used by the render pipeline as a parameter. And then when you have pressed a space and the fade out is finished, it switches off some pipelines and enables some of the other ones that you have seen at the root. It enables the ones for the level and the gameplay, and enables the one for the introduction. So that was here. Then this could be considered a game logic process. Then I'm going to show the render process, which is the other type of process that we have here. But I'm going to show the one for the levels, which is a little bit more fun. Okay. This one is quite complicated too, but I will speak about the pipelines being complicated later. Okay, what does this do? It takes a scene that has already been selected by the logic, and it's going to render it. So it takes all the objects. From the objects, one is the special, is the camera. It's going to be used. Okay, maybe I start for this part here. You take all the objects, and for every object, you set the parameters on the shader and render it here. The screen is also a data type. It's taken by this module. It renders everything, and then it's taken by this other module, and then finally it's presented to the user. Here I'm trying to represent a shadow mapping pipeline. So that's why it's a little bit more complicated than a normal render pipeline, because I'm rendering the things twice. Once here from the camera point of view, and once here for the light point of view, and the texture, the image generated in this part of the render pipeline is used as a parameter for the materials to perform the shadow mapping. And this is only debug if I'm going to change this to hide it. Okay. So currently the rendering system is using OpenGL 1.5 with some extensions to be able to do nice render to texture and use OpenGL shading language. But the shaders are quite simple. I just implemented the per pixel font to use the same material that uses Blender by default. Okay. Finally, I'm not going to explain more of them. This other controls the platform, and this other here advances the physics. Well, I'm going to explain this one. The one for the physics is quite simple. It takes also all the scene that contains the physics environment. There is a module that is in charge of updating it, and it outputs a list of collision events every frame, so you can check if objects collide and generate different events. For example, here I'm only checking if an object called ball collides with an object called exit, and then it switches the level. Okay. So now I'm going to show this working, hopefully, with a very simple example. Okay. That's the intro scene. Don't judge me as an artist, please. And this is what happens. Now, what you see here running is the pipelines that have been defined visually here. As you see, the shadow mapping has some obvious problems in the borders and also precision. That's why you see sharp edges in some places. But all the control is done with these pipelines. So now the collision has been detected, and there is another level. So I have to increase the damping so it doesn't bounce so much. Anyway, to develop this, I've been trying to do something like this, more or less, with all the ingredients of a small game, which is processing the input, processing events inside the game, and also trying to define a slightly different graphics pipeline than the one that has the normal game engine, which doesn't support shadowing. Well, I think there is in Tohoku there is a patch that does this, but not in the main branch. A ball what? Yeah. Yeah, I can try to do this. No. Exactly. All these pipelines work only with the data that comes from Blender. So once you have defined this, for example, right now I have these scenes in Blender. One is the intro one that has this special name. It's looked in here. But all the others are treated as levels. So if I want to create more levels, I don't have to touch anything from the pipelines. It's only Blender work. And if I want to change the materials, I can do it in Blender. Right now I'm reading the properties of the material Blender. Where is it? Okay. It's not defined here because you don't define the material for a certain object. Here, this is like a program. It treats random data. So the material comes from the data build pipeline. It is read for every object, Blender object, which is the normal object that lives inside Blender, in here. And it's converted to the material for the game engine in here. And from here on, it's only a shader, an OpenGL shader, so it's no longer a Blender material. But if you want to change the material of ball, you just go into Blender, into material properties, select the, it's here. Select the ball, and not a very good user of Blender. Where's that? No, I already have. Okay, the ball doesn't have a material. That thing you've seen is the default material. So, yeah, let's add a new one. And let's make it, there's nothing red. So let's make it red. Now I should check that I don't have it. Let's reduce specularity, make it easier. Okay, is it red here? Yeah. Now hopefully it should be red in the game. For the first level, at least. No, it's not. Okay. I'm reading the properties here, but maybe I have to. Okay. Probably the thing is that I'm mixing. If you render this in Blender and see at the rendered image and check it in the game engine, you will see that the proportions of specular colors, diffuse colors, and these kind of things are not the same. So I'm probably mixing them too much, and the specular color, well, it should be red also. But anyway, the idea is to get all the data coming directly from Blender and not having to define anything else for the pipelines. So, yeah, I've been talking about this at the beginning of focusing into simpler games, and we've seen some games working, well, some Blender data working on mobile phones, and I spent some time in doing something similar, but not with mobiles. I wanted to make sure that the overhead introduced for having games running with this engine wasn't very big. And that you weren't wasting your CPU cycles with processing all these graphs and this stuff. So I made a small port, it's a partial port only, of the generic game engine that can run the data created in Blender. I'll try to show it. It works. It's not a very powerful machine, so it's not very fast. Oh, I forgot to mention this. A part of the integrated game engine, I have a standalone player that works with the data generated from the engine without having all the rest of Blender to make standalone, or that could be eventually turned into a web plugin. That's here. With these functions, with this button here, what I do is run the data build pipeline, or all the pipelines marked as being data construction pipelines, and then serialize all the data into a single file that contains all the game data, and also generate all the process into that same file, so it can be played outside Blender. Okay, it seems that it's working now. Okay, this is a small port of the game, only to show that the overhead introduced by these pipelines is not too much. This has a very small processor compared with the one on the PC, and it's running exactly the same code. And well, actually, a part of the shadow mapping that I didn't implement because the support, well, the graphics here are not working with OpenGL, so I have to use another library that I don't know very much yet. So the idea here is that you can build whatever here. Just click on build, and take the files generated here and copy them to the PSP in this case, or whatever other device, and try to run it. So I wanted to make it portable and check that it's fast enough. You will probably make the ball fall outside the limits because of the floating point precision is not very good for this machine. If you lose the ball, you will have to reset the game, because I haven't implemented logic to restart or to detect that the ball falls. Okay, so as you can see, this is far more complicated than what you have in the normal game engine. I don't think that artists alone can really define these pipelines to create a game, with all the respect for the artists, of course. But I think that we can have some standard pipelines that even try to replicate what you could see in the previous game engine, and they could use that and define only logic pipelines or things like this. But, well, this is part of the discussion I would like to have in the end. In general, I think I've been trying to get the benefits of scripting and the benefits of flexibility, of breaking the rules of the tree chain in the game engine. But maybe what I really get is the worst part of both, meaning that this is almost as complicated as scripting, and it's too complicated to use for the ones that were used to the the normal game engine in Blender. So that was the example. And now some ideas for what I'd like to do in the future. In the short term, this hasn't been documented apart of in a thread in a forum. I would like to write a little bit on this and explain how it's done, so if anybody else is interested, they have a place to start. Then to develop this, as it's, at least for me, it's quite experimental, and I wasn't sure of what problems I would be facing. What I did is to define milestones in the sense that I would like to be able to do this, and then evolve the system until I'm able to do it. The first milestone is this small game that you have seen. So I would like to define what the next milestone, what I would like to see there. Probably, as I'm a graphics programmer, probably going to involve more graphics than anything else. Then the weaknesses I've been talking about, the definitions of these pipelines graphs, had to be solved, because if not, you can very easily produce graphs and pipelines that don't work, and that should be avoided. And then, of course, I would like to extend the number of modules. Currently, there are around 60 or 70, but most of them do very simple things at low level. In long term, as I said, I would like to have a set of pipelines that could be used without having to know what's happening in there for the people that's not technical but want to use this engine. The editor has to improve a lot. There are infinite things that you can do in the editor to make it better, but that was just only the simplest implementation I could make. And then try to define more advanced milestones and see where, what points can you reach with this approach to developing the games. And that's all. I would leave this for the end. after the other presentation on game engine. So we can, if you don't have anything that is very specific to this presentation, we will leave it. So, any questions? Yeah. Well, no, but it's very easy to implement a module that, in fact, takes a Python script and processes the input and the output. The only thing that we should make to have this in Python or any other language is to wrap the types of data that can flow between the modules. Right now, even if you have 60 modules, you only have like 10 different types of data, being mesh or being material or being floating point or being vector. So it wouldn't be difficult to wrap that and add a generic module that you can put a script in Python or whatever. No. I've used only the user interface code to define buttons and everything. All the logic code is still there in the other section of the game engine. I haven't reused that, meaning that the classes representing sensors, actuators, or anything haven't been really used for this. Sorry? I'm using the C code for the interface in Blender, and the link buttons, I'm not sure if they are defined in the game engine or in the normal user interface code in Blender right now. But I'm using the same link buttons there with the images and... Yeah, it's good. Mm-hmm. Mm-hmm. Well, actually, I think that the buttons to make links are already out of the game engine, are part of the main user interface library, and they are quite easy to use and define what can be linked with what. So, no, this is something I haven't done. I have to confess I'm a little bit scared on the complex way of handling the save of data in the blend files. And as this was done as a quick test, the save and load is happening in a completely different process and different files that are in fact text files because they were easy to parse. So that format is completely temporary. Of course, in the end, if this goes on, it should be part of the blend file. So it should be using the make SDNA system to store everything. Well, I have a functionality in the editor that it's in the button build data that takes all the pipelines in the root level, the ones that are marked as being data construction, and I run all these data, all these modules, and then I take all the data that has been emitted for these modules that is waiting in the other pipelines to be processed and serialize it to a single file, and also serialize the pipeline. So you only need the data, the pipeline description, and the executable to run. That is what I had to port to the PSP. But that's the only thing. I mean, there is nothing specific of this example in this process. It could work with other things if there was anything else done with it. Yes. Yes. The game engine is using its own data types for the runtime processing. It has its own mesh type, its own material type, because they are very different from the materials in Blender. Materials in Blender and meshes in Blender are thought to be used when you are editing things. So you have lots of links between the different elements of meshes to make algorithms efficient. But you don't need all this when you are rendering a mesh for a game. Usually you only need vertices, faces, and even not need to know the contiguity between faces or anything else. So it has to be much simpler. It's transformed to a format that is more friendly for the graphics hardware. And in fact, the current game engine is doing something similar. When you run a game, the first thing it does is converts most of the things to its own data types, and then it goes on with this for the rest. So this hasn't really changed a lot. Mm-hmm. Mm-hmm. Yeah, this is one of the improvements that could be good for the editor, to show in the connections that a little icon showing what type of data in there. However, when I said that you can build things that don't work with the pipeline editor, I wasn't saying that you can plug a material in the place of a mesh, or you can plug a vector in the place of a material. This is already controlled. You don't see it because I'm not showing these icons, but the connections filter the input. I mean, you cannot really connect things that don't match. The main problem with the connections is that mainly the order of the data flowing. You don't know what order is it going to be. So some processes need, for example, when you're rendering meshes, you want to know, sometimes you want to know the order of them, sometimes you want to, and all the times you have to know when you are not going to get any more meshes, and you can just go on doing something else. And if you just have a flow of meshes without having at least an end of data signal on it, you can't do really this. So. Mm-hmm. Mm-hmm. Yeah, yeah. Mm-hmm. Yeah. However, I would try to avoid making these things more complicated, and I think that there must be a way to get it working intuitively without having to enter numbers and more data into the pipelines. Maybe we can just define some restrictions on the way the modules work, so you don't have to care about this, and whatever you can construct, it should work. So, yeah, I'm a little bit concerned about it being too complicated. That's why I don't want to add more input for each module you are trying to create. So if that's everything, I'm going to leave.